Hello student. Now we learn about the electric generator. We have seen the experiment based on the electromagnetic inductions. The last topic. The current produced in this experiment was a very small magnitude. But now, on the same principle, can be harnessed for the use of mankind to produce a large current. Electric generator is useful for the mankind's for the various type of the use. Electric generator means it generate the electricity to useful for the mankind's in various equipments. It is based on the Faraday's law of the electromagnetic induction. Its principle. Now we discuss here. The generator works on the principle of electromagnetic induction discovered by the Michael Faraday. What is the Faraday's law? An electromagnetic field induced in a conductor, that is the coil. An electromagnetic field, that is EMF, is induced in the conductor when the magnetic field around it changes. The magnitude of the electromagnetic field is proportional to the rate of the change of the field or the rate of the cutting flux, while its direction depends on the direction of the rate of change. A coil of electric generator rotates in the magnetic field, induces a current in a coil. This is the simple principle where I discuss the law of the Faraday's law now. But the main principle, that is the coil of the electric generator rotates in the magnetic field. When coil rotates in magnetic field, it produces a current in a coil. This is the simple line of principle. There are the two types of the generators actually. Types of generator: AC generator and DC generator. The AC generator produce AC current. The generator which converts mechanical energy into the electrical energy in the form of the alternating current is called AC generator. And the DC generator, a generator which converts the mechanical energy into the electrical energy in the form of the direct current or DC, is called as DC generator. Working of the electrical generator. This is the figure shown in your book. 4.20 figure number shows the arrangement. Before that, we have to discuss how it is worked. Most of the metal have electrons that can move around freely. These electrons allow electricity to move through the metal, transmitting electrical energy from one place to the another. These metals are called electrical conductors. A generator is a device that is used to move electrons through a conductor to give electric power. Simple. The electrons move through the conductor and give us electric power. It does this by using the magnet that forces electrons to move along a wire at a steady rate while putting pressure on them. With the help of generator, the electrons can transmit electric energy from one point to the another point. The difference in the number of electrons and the pressure that the generator applies is what creates the different electric current. The generator spins it at a certain number of rotation per minute. The number of electrons that moves is measured in amperes, and the pressure is measured in volts. This is the figure of the AC generator. In this construction, the main component of the AC generator are, as look in the figure, the armature coil. This is the armature coil. Strong magnets, north and south. Sometimes here is a south and north. This is the strong magnet. Split ring. This is the split rings. Two are the split rings. And brushes. This is the brushes. Brushes and split rings are like this. When it is touched and connected, it is separated by some distance. There is some point that is at one end point. It is a certain point. It is a touch and then current flows like this. This is arrangement going through this is the unit. What we say? It is a galvanometer. That is, the galvanometer is useful for the measuring the electric current in the device. This is the axle that is used to connect, that is coil, and it is rotated, and we use the various types of the equipments in our daily life. This is simple. Actually, it is based on this principle, which is that this is the right hand rule. Fleming's right hand rule. Motion of the conductor by like this. Motion of the conductor by the thumb. Direction of magnetic field, that is from the first, and direction of the induced current by the second. There is a copper coil, A, B, C, D. This is the copper coil kept between the two poles, pieces of a magnet, north and south. This is the piece of the magnet. The two ends of the coil are connected to the conducting rings R1, R2, R1 and R2. This is the conducting rings via carbon brushes. This is the carbon brushes. That is, we indicate by B1 and B2. Both the rings are fixed to the axle. This is the axle which is connected to the coil. But there is a resistive coating in between the rings and the axle. There is a resistive coating. When an axle is rotating, then there is a resistive covering on these rings, and when there is open, it is touched to the B1. And if B1, then it is started to going for this movement like this, and it is going through toward the B2. Resistive coating between the rings and axle. The axle is rotated with the help of the machine from the outside. There is a machine from outside by which it is rotating. Means sometimes we use the flow of the water in a dam, or sometimes from the air in a windmill like this. Due to that, it is rotated, and when it is rotated, then there is a magnetism the field which is used here, and the coil is kept in that magnetic field. ABCD start rotating. The stationary carbon brushes B1 and B2 are connected to the galvanometer. These are connected to the galvanometer. Galvanometer, which shows the direction of the circuit upon the rotating the axle. When it is rotating, and it shows the direction left or right. If there is a clockwise direction A, B, C, D, there is clockwise direction, it shows the CD and from AB goes up and CD goes down like this. This is the movement, that is clockwise direction. According to the Fleming's right hand rule, Fleming's right hand rule works like this. This is the CD branch, and the current it is induced, it is flowing through that CD branch like this. This is the motion of the conductor, this direction, motion of the conductor. This is the magnetic field, and the current induced in this way. This is the magnetic field. This is the motion of the conductor, and this is the induced current. The current where is it is produced, it is flowing through it, as well as it is when circuit is completed, then it is go through A to B. Means the current produced in the branches AB and CD in the direction A to B and C to D. Thus the current flows from A, B, C to D like this when it is rotate. At the external circuit, the current flows from B2 to B1. It is a B2 to B1. This is the external circuit through which the current is passing through the galvanometer. Instead of the one loop coil, a coil consists of the several turns used. Here is a several loops are used, and the current in the magnitude several times flows after half rotation. When CD pressurized, AB goes in upward direction and it is going to this side, and CD comes here and AB comes here. Due to that, it is the changes the direction of the current. Means now the current is flowing in disward direction. This current is now, when it is a changes, it is a half rotation in 180 degree. After half rotation, the branches AB takes the place of the CD, and the CD branch take place of the AB. Therefore, now the current going from the D to C to B, then A, means it is going to the reverse direction. The branch BA is always contact with the brushes B1, and the branch DC is contact with B2. Now it is the changes, and the external circuit current flows from B1 to B2. There is a changes, means it is the opposite. Previous the half rotation. The repeat after every half rotation, an alternate current is produced. This is what is called as AC generator. In a DC generator, there is a simple change are made. There is no use of that R1 and R2. There is a use of the split ring. This split ring is contacted like this. This is this position, and due to that, when axle is rotating, there is no another two sides. It is in one side. B1 and B2 are connected here. The DC does not change the direction in the external circuit. A split ring is fixed in the axle like a split ring is used in electric motor. In an electric motor, there is a split ring are used here. Because of this arrangement, the branch of the coil going upward is always in contact with brushes. Due to that, it is always in contact with the brushes, and the branch going downward is always contact with the other brush. Due to that, it is a half rotation, it is always in contact with brushes. Hence the current flows in one direction. There is an alternate direction. When it is a half rotation, there is a direction changes of the flowing current. Here no direction changes. If it is going, and that is the only brushes contact is changes. The current flows in one direction in a external circuit. This is why this generator is called as a DC generator.